Soundity sound. Welcome to transformations and domain and range of logarithmic functions. So we're going to start by looking at the transformations of the logarithmic parent function, which has pretty similar transformations to the other types of functions we've done this year. So you still got your a, h, and k. So for our a value, we're actually going to do a few examples of that because that is where most people get confused is the a value. You guys are pretty good about h and k. So the a tells you if there's been a vertical reflection, a vertical stretch, or a vertical compression, or more than one of those. So here's where the confusion sets in that I see. So for example, let's say our a value is a -2. So I have -2 log of x, let's just say is my function. So in this case, since I've got a negative sign, that's going to be a vertical reflection. But notice the 2, since it is greater than 1, is also going to be a vertical stretch. So if you have a negative number sitting in front of your log, you may have 2 transformations going on here. So just kind of keep that in mind. Or let's say, for example, I've got 0.5 times log of x. Since 0.5 is between 0 and 1, that's going to be a compression. And since it's a positive number, there's no reflection. So this one has just a vertical compression. Or for instance, if I have negative 0.1 times log, that's a 1, times log of x. So I've got a negative, which is a vertical reflection, but I've also got this 0.1, which is between 0 and 1. So that is a vertical compression. So hopefully this helps clear up a little bit of the confusion that there has been over this a term in the past for the past functions we've done. Just remember that if the number is negative, then you may have 2 transformations instead of just 1. Then your h value, of course, is just your left and right. So remember, if it's x minus a positive number, you're going right, and x plus, which is x minus a negative, is left. So the sign is kind of the reverse of what you would expect it to be. And then k is your up and down, or up or down. Now, logarithmic functions also have a vertical asymptote, which is at x equals k. So whatever this number is, as long as your function is written in this form, that's going to be your vertical asymptote. And you can see it real easily on the graph too, because you're going to have your function and you won't necessarily see the dotted line depending what calculator you use, but you will see a pretty obvious, almost vertical portion of the graph there. So, and this affects the domain of the function. Okay. On the inside here, every logarithmic function has a vertical asymptote that affects its, check the previous page if you don't remember. So it affects its domain. Now the range of all logarithmic functions, so your up and down, what y values can you have is going to be all real numbers. So for a logarithmic function, your range or your y values will cover all real numbers. So on these examples, we're going to do the first 4 on the video, and then I'm going to leave the last 3 for you. You'll have to type them in Desmos first if you want to be able to look at the graph for them, but you're just going to do the same thing that we're going to do up here. So we're going to do domain, range, transformations, and vertical asymptote for each function. So first I'm going to look at this first example. I have log base 2 of x minus 3. Now I didn't put parentheses on this one, but they would be right here. So that minus 3 is outside the parentheses. So just be careful of that. I'm going to just erase that to keep things cleaner here. So that's your k value. That's your up and down movement. So this function moves down 3 compared to the parent. And remember, the 2 is just your base. It's the base of your log, so it is not a transformation by itself. Okay, so it's not a transformation by itself. It's just part of the function in this case. Now, my vertical asymptote, you can see it right here on the y-axis. So my vertical asymptote is at 0. My domain then is, so my smallest x value is going to be 0.0000000. You know, it just keeps getting closer to that 0, but it's never going to touch 0. But then my x's can get as big as you want them to get from there. So my domain is going to be x is greater than 0. And if you want, you can write it in this notation as well. Up to you. And then my range is going to be all real numbers. Next one. So I have a plus 1 inside the parentheses, which means I'm going left 1. And you can see that my vertical asymptote is now at -1. So instead of being at 0, it moved left 1. And my vertical asymptote is now at x equals -1. And my domain, I go from -1, but I never touched -1. And then on up from there. So x is greater than -1, or you could say -1 to infinity. That's fine too. And then my range is all real numbers. Third one. So, I've got a 2 sitting in front, so that's going to be a vertical stretch. And then I've got a plus 1. Notice it's not in parentheses, so that's going to be up 1. I've got my vertical asymptote at 0. So vertical asymptote at x equals 0. My domain, just like the previous one, is x is greater than 0. And again, you can write interval notation if you want. And my range is all real numbers. And then finally, I have ln of x minus 3 with x minus 3 in parentheses. Remember, ln is just log base e, so it's the same old thing. And since my minus 3 is in parentheses, that means I'm going right 3. I can see my vertical asymptote is right about there. And since I'm numbering by 2s, 2, 4, 6, 8, 10. So between 2 and 4 is 3. My vertical asymptote is at 3. You can also tell by this where your vertical asymptote is going to be. So x equals 3. Then my domain is...
Dr. Cherry, please call extension 7248. Dr. Cherry, please call extension 7248.
So my domain is x is greater than 3. So I've got my asymptote at 3, and it goes up from there. And then my range is all real numbers. So again, go ahead and try the next 3, graph them in Desmos, make sure you can do it, and then you've got an assignment. Don't forget to let me know that you're ready for help.